Hi everybody, welcome back. We are 9.2 quadratic inequalities with one variable this time. So this basically looks like an equation that we're going to factor and solve. You'll notice that we have one variable. Now we have a squared term, so these are essentially quadratic equations. But now we're going to have the inequality sign with a quadratic. So that's the only really new part here. And there's a few different ways that, a few different methods how we solve these. So first, just a quick recap of how to factor. Remember, we got to factor; it's extremely important moving forward. So the first one we have is x squared plus 2x minus 8. Two numbers multiplied together give me negative 8. Added together to give me positive 2 would be 4 and negative 2. We solve, so obviously the x values to satisfy this equation would be negative 4 and 2. Basically, your x-intercepts, right? So x squared minus 4x minus 12, same thing. We factor, we get negative 6 plus 2. Solve, we get 6 and negative 2. Same thing here in the last one. Okay, so again, that's just a quick recap of how to factor, right? So now we're going to take a look at this function. So it says consider the following function: f of x equals x squared minus 3x minus 4. Determine the zeros of the function. So that turns it into an equation, right? So we set it f of x, which is essentially our y value, equal to 0. We solve for the two x values. We get x equal to negative 4, x equal to negative 1. It says sketch the function on the graph provided. So that's what I've done. I have the x and y intercept. I also have the two x-intercepts and also the y-intercept, and I've gotten the vertex as well, and I've sort of sketched. Now, if we sketch, you wouldn't have to have the vertex perfect, just some of the key points there, especially for these questions. It doesn't have to be precise, but you definitely need those two x-intercepts. So now let's switch this equation into an inequality. So it says identify the x values that work for the inequality x squared minus 3x minus 4, which makes it greater than the 0. So that's essentially above the x-axis here, which is interesting. So the values that are going to satisfy, this here should be x equal to negative 1. I'll fix that. I do apologize. And that is x greater than 4. Sorry, I just had to fix that. X equal to negative 1. And x is greater than 4, right? So everywhere under here, okay, that's when it's less than 0, and that's when we have a y value greater than 0. So that's essentially what it is, right? Because this here inequality is saying x squared minus 3x minus 4 is greater than 0. So basically we're letting y equal 0, right? So when this is greater than 0, it's above the x-axis, which would be when x is less than negative 1, when x is greater than positive 4. And it says identify the same inequality, only now we have it less than 0. So that's when the y value is less than 0. So right here, this part here, and that's between negative 1, negative 2, negative 1, 0, 1, 2, 3, 4, there. So all the values of x that satisfy this inequality will work. And I will show you how to do a test point on that a little later on when we're doing one of our methods. So how to solve a quadratic inequality. So there are several methods to do this, and the first one we'll do is we'll graph the function, and that's what I just talked about here, and then I'll show you how to express the value as in the solution set. So determine the solution for x squared minus 5x minus 6 is less than or equal to 0. So remember, start by finding the zeros of the function. So I've sketched the curve. X squared minus 5x minus 6 is equal to 0. I factor, I get the two x values, x equal to 6, x equal to negative 1. I sketch my graph. Again, we have negative 1, 0, 6, and 0 for your x-intercept, and your y-intercept obviously comes from the original right here, which is negative 6. And then the vertex, you can find it as well if you want to graph that. You guys know how to do that. We can do minus b over 2a, whatever you want. I just sketched it on my Desmos program. Okay. And it says determine the solution to x squared minus 5x less than or equal to 0. So we're worried about all the points that are less than and equal to 0 for y. So that's all the values underneath the x-axis, right? So there's y equal to negative 1 and 2. So to satisfy that, it's all these points underneath, right? So the solution set is negative 1 less than or equal to x, less than or equal to 6, and x is an element of the real numbers. So that is the proper notation. You can do interval notation if you wish. I did set notation. It's up to yourself. Okay, so that's how you graph the function. We know how to graph that. That's easy. So now we're just looking for the solution set. So if you were asked to find, to solve the inequality here, to satisfy this, this is your answer right here. Okay. Roots and test points using a number line. So this is another method. So to have the equation x squared plus 7x plus 6 greater than or equal to 0. So start by solving the related equation. So we put 0 in for true. We solve and we get the two values, right? So this means that we plot a point here at 6. We have a solid point because it's in less than or equal to or greater than or equal to, so the point is included. If it was just less than or greater than, we would keep that as an open circle because it's not included in there. And it says draw a number line, so there's your number line, and do some test points. So just pick points that are less than -6, greater than -6, or less than -1, greater than 1, right? So I picked -7. I plugged it into the original inequality. I got 6 is greater than 0. Yes, it is. So that's included. So that we know this region's not, because they're going to alternate, right? So this can't be included, but we'll double check it. So I picked 4. You could pick any values in here: -5, -4, -3, -2. -3.5 doesn't make a difference, and it won't satisfy the equation. And then this will. So they will alternate. When you pick 3 values, you remember. So you plot your 2 x value points. You get from factoring using its roots, so -6 and -1. -6, -1, so I'm going to pick a point on the left side of -6, between -6 and 1, and on the right side of negative, right? Just like a number line. And so the solution set is x such that x is less than or equal to 6, or y is greater than or equal to -1, because it's all the values greater than -1 and all the values less than. The ones in between here, they do not satisfy the inequality, so therefore they're not part of the solution set. And there's your fancy set notation. If you said x is less than or equal to 6 and x is greater than or equal to -1, I'm okay with that, but I just want to show you some of the fancy notation that some of your teachers may require, right? So I just like to show you different ways. Okay. The roots and test points using a chart. I don't think we need to use this method, but it's another method they want to show. Might be better organized for you. I don't know. So then I have the -x squared plus x plus 12 is greater than or equal to 0. So remember to find the points. So if we have a negative in front, what we'll do is want to factor that out or divide by. Once it's set equal to 0, you can divide the negative out. Same thing. Either way, you get your x values at a +4 and -3, or vice versa. So I just set these up into a chart. So your interval is going to be, remember, the x is less than or equal to your smallest value less than or equal to x less than or equal to your largest value, and then x greater than or equal to your value. That'll always be the case. So the first interval is going to be the x value that's less than or equal to, or less than, whatever the case may be, of your lowest value. Then this is your in between, right? -3 less than or equal to x less than or equal to 4. So your lower value less than or equal to x less than or equal to your higher value. And then x is greater than your higher value, obviously, just like the number line indicated before. Pick a test value or a text. I don't like the value point. Maybe I should say text point or text, a test value, whatever the case may be. So it's just an x value that's going to work. So our x value is -5 because that's less than -3. You can pick -4. You can pick -1,000,000 if you want. It doesn't matter. I just try to pick values that are easy. So put -5 in, we get -18 is less than or equal to 0. That's a no. We know this is going to be yes, then we know this is going to be no. They will alternate your solutions. It'll be either yes, no, yes, or no, yes, no. You'll notice that pattern happens as you continue. Then I picked one in between because one's negative, one's positive. I obviously picked 0. It's easy to solve. Put it into your original. 12 is greater than 0. Yes, it's true. Still solve them all, even though we know the pattern works. Put in 5 because it's greater than 4. Plug it in, we get -8 greater than or equal to 0. We know that's not true for the original. So we have no, yes, no. So that means our solution set is right here. That's it. It's either yes, then to be these two. It's either going to be basically in between or below and above. Pretty straightforward. And then we state the intervals that satisfy. So there's your answer. X is x such that negative 3 is less than or equal to x, less than or equal to 4. X is an element of the real number system. It says solve the following quadratic inequality using a method of your choice. So I've done that here, done the exact same thing that we done above, only I just put it in a form here, like in a chart form. So the first one I did by graphing, C I did by graphing, B I did using a number line, and D I did using a table. You can work through those examples. Try them on your own. It's done exactly how I did in the previous couple of pages, and there's the solutions. If you see any errors, let me know, but I think everything is pretty good there. Okay. So the questions that go along with the textbook are on page 485, and numbers 1 through 9 will be part of section 9.2. If you have any questions, please contact me, and that's it for now. We'll pick up at 9.3 a little later on.